Quadratic function transformations and functions should remind you very much of everything that you learned during the absolute value unit. Our parent function, rather than being V-shaped, is now U-shaped, and that's our unfancy definition of a parabola, a U-shaped curve. This is the parent function of the quadratic function. That is because negative 3 squared is 9. Well, negative 2 squared is 4. Negative 1 squared is 1. 0 squared, 1 squared, 2 squared, and 9. Only a few of those points fit on the graph. 1 and negative 1, 1, 2 and negative 2, 4. Now, when we multiply the x squared by a coefficient a transformation happens. When that a is greater than 1, the graph becomes steeper. We say that it is vertically stretched. So the one I'm highlighting is 5x squared. It is vertically stretched compared with the parent function, which is right here. The one in the middle is the parent function. So 5x squared is steeper, it's vertically stretched compared to f of x equals x squared. When a is a fraction between 0 and 1, the graph vertically compresses, or we think of it as getting flatter. So when we compare h of x equals 1/2 x squared, it is flatter and compressed vertically compared to f of x equals x squared. Just like with our absolute value function, when we multiply x squared by negative 1, so we had negative 2 squared, which was 4, and then we make it negative, so negative 4. Negative 1 squared, and then multiply it by negative 1 is negative 1. Negative 1 times 0 is just 0. 1 squared is 1 times negative 1 is negative 1. 2 squared is 4, make it negative, negative 4. So the graph is reflected over the x-axis. You can just say that it opens down. Just like with absolute value, when we are adding or subtracting h within the parentheses, we are moving the graph left and right. So when we have a minus h, we go right, the opposite of what you would think. When we have a plus h, we go left. Parent function will stay black in the middle. And then first, let's look for g of x equals x plus 3 squared. The plus 3 is going to move it to the left, the opposite of what you think. Plus 3 units to the left. In contrast, when we have h of x equal to x minus 2, that's going to move 2 units to the right, 1, 2, and that will be this graph. So parent function in the middle, moving to the left for x plus 3 squared, moving to the right for within the parentheses x minus 2 squared. Absolute value, when we had a plus k outside of the absolute value, we went up. When we had a minus k, we went down. Same thing here. So j of x, we have x squared minus 3. Parent function in the middle, we are transforming the parent function so that we shift it down 3 units. So when the 3 is outside of the squaring, we move it down. When it is inside, when a number is inside, we move it left or right. Final one, no parentheses, x squared plus 2. We're going to take the parent function and shift it up 2 units. So x squared plus 2, we go up 2.